start, and I am recording the session, and this recording will be posted on YouTube on a private channel or actually with a listed channel. I'll be sharing the link with you on Moodle, and as you may recall, we are going to talk about arrays this week, and we started with arrays last week, and we have covered certain aspects of arrays. Specifically, we did the one-dimensional arrays. And if you recall, an array is a convenient way of keeping track of a series of entries or series of values of the same type through a single name, variable name, right? So in the case of a one-dimensional array, we had a list of entries. It doesn't matter. Let's say how. So you have the number of entries you want to actually keep in a single variable of the same type, and we saw that we could actually keep a list of entries or a vector of entry or those type of things in a single array. And we have seen how to actually access those array entries and how to read them, how to write to them, and how to actually pass them to a function in order to actually use a set of values or pass a set of values to a function for further processing. And perhaps also processing might include changing the values that you send to the function. And we have discussed that quite in depth last time. We looked for, let's say, some algorithms where we can actually implementation of an algorithm as a function that could find the maximum entry in an array and returning that as the first entry, and the rest is actually the same. Or we also discussed how to do a sorting of an array. So if you have an array of a certain number of entries, we said we can actually change those according to an algorithm, like let's say having an ascending order sorted array or descending order or whatever. Now, of course, arrays are not limited to just a single dimensional list of entries. You might have actually tables of data, multidimensional tables of data. So, for example, you might have, let's say, guys, you should not be actually asking for presentation. Please refrain from doing that. Okay, anyway, so one example could be, for example, you might have your, let's say, courses and your students, and each student's, let's say, passing grade on a course. So you might have, let's say, a simple array where, in this case, or simple table where you would have something like this. Let's say that I have entries like this, right? So this is a multidimensional array or table. So, for example, you might have your courses here, CSE102, CSE108, and so forth. And then you might have, let's say, students here, student 1, student 2, student 3, and so forth. And then you may want to actually keep all your, let's say, grades, the passing grades or failing grades, whatever they are, in this thing here. So this would be, let's say, for example, 95 for a person that actually took or got 95 out of CSE 105, or maybe this is 67 or 68 for the student number 2 to actually for, let's say, math, I don't know, 208, let's say, right? Something like this. So this is a table, and you can see that you can think that you might want to actually keep this table in a single variable. I might say, okay, I want to keep this table in a variable called grades, for example. And what I want to do now is actually I want to be able to access a student's grade for a specific class. So you can easily see that for given student, for example, the second student here is actually, and then this third class or the fourth class here, the student actually got a 68 from this class, from this course. So we knew how to do this for a single student using a one-dimensional array. Like here, I would say, so for example, this is a one-dimensional array, this part here. One student is actually a student's grade for each courses that he or she has taken, right? Now, what if I want to do this for multiple students? So I have this two-dimensional table that I want to actually represent as a single variable. And we are going to see that C provides us with a mechanism to do this. And this is called multidimensional array. Of course, your tables should not be limited to just two dimensions. In this case, you have two dimensions. One is the course here, and you have also here in this dimension, you have the students. So you might have also another dimension here that could actually give you, let's say, not just the just one entry, like let's say the GPA, or not GPA, but let's say the passing grade. You might have, for example, midterm grades, and then you might have the final grade, and you might have, let's say, homework grades, and then you might have the total or the average grade that you want to actually have. So in this case, now you have a table of three-dimensional table. In one dimension, you keep your students. In another dimension, you keep your classes. In a third dimension, you keep your, let's say, types of scores that you actually want to have, right? So in that case, I can ask student number 1 for CSE 108 for homework 2 got this grade. I want to keep it there. So in this case, I have a three-dimensional array. So the first dimension has the number of students, as many as the number of students, entries, as many as number of students, right? And then the second dimension is the number of classes, or the classes itself, the courses itself. And the third dimension, different types of, let's say, number of different types of grades that I want to actually keep in this one. You can see that I'm talking about grades as individual entries in this table, in this multidimensional table, and they are integers perhaps, or maybe a floating point number. Now the question is going to be, how do I actually keep this thing in, let's say, in an array? So the way that to do this, of course, one-dimensional array is not going to be sufficient to do this one, because in one dimension I can only keep a student's, let's say, courses, students, let's say homework 1 average or homework 1 scores of a student on on all the courses. This could be kept in a one-dimensional array, but this three-dimensional array cannot be kept in such an array. So what C allows us to do is, C says, okay, I will let you do this one. And it's very simple. It's very similar to what we had before. So if you have, let's say, integer grades for each of these, you have an integer type. So this means that for even the multidimensional arrays, I'll need to define the type of the particular entries that I'm going to actually keep in each of these in each of these cells in this table. And then I'm going to talk about, and I'm going to give a name to it. So I said grades already, we decided on this one. And then I will actually now define a multidimensional array, very similar to a single dimensional array. This time, I'm going to actually indicate the number of entries for each dimension that I have. So if I have, for example, the first entry is, or the first dimension is a student dimension. So here I'm going to have the number of students. For example, let's say in our class, we have about 156 students. All right, so maybe let's say for computer science or computer engineering department in our school, maybe we have, let's say, I don't know, maybe 450 people. So this is the number of students that I will actually have in that particular multidimensional array. So this is one dimension. This is this dimension. So this is the how many entries I'm going to have in this dimension. And then I will have the number of courses. For us, the number of courses could be, let's say, maybe, I don't know, 40 of them. I have 40 courses all together. So this is the second dimension. And then for the third dimension, the different number of entries or the, let's say, scores that I might want to actually record for each course. So homeworks, perhaps, maybe, let's say, midterms, maybe multiple of them, maybe quizzes, and maybe a final, and maybe even a makeup final, and so forth. So perhaps this is, I don't know, maybe 10 of them. For our case, if we have homeworks considered as single entries, then we might have many more than 10 actually. So now what I am saying here is that I have a variable that will give me a multidimensional table, three-dimensional table, which will have, let's say, in the first dimension, 450 entries. In the second dimension, I'll have 40 entries. And then in the third dimension, I will have 10 entries. So the total amount of entries that I will have in this particular table is going to be, of course, these numbers multiplied together, right? So I'll have 450 times 40. This is this many students times this many classes times that many different scores that I want to record here. All right. So this would make 450 times 40 times 10. So it will be a large number. And this specific labeled grades or the variable will keep all these entries for me. Now, similar before, if I want to actually access this entry now, for example, let's say I want to actually know something about, or I want to restore the, let's say, the student index by 1. This is this student, the second student here. And then maybe the second course in my list, which is gonna be, again, 1 here. And then maybe the final exam that this person actually attended, perhaps that is index 10 here. Now, this is a way to access this particular, one particular cell or one particular entry in this thing. So I can use this as part of an assignment, as an argument to the left hand side or on the left hand side of this thing, or I can also put this as a, let's say, as a value in an expression, wherever an expression can be used, right? So this is how I would actually access to get access to entries of this table. There is another example on my slide here that I am actually having a tic-tac-toe game A tic-tac-toe game, if you recall, is a 3x3 table or a matrix of 3x3. And what I am doing here is that I am assuming that I will fill in the entries of this 3x3 matrix by characters, with characters. In particular, I would have only O as a letter O and letter X, and perhaps as an empty, which is not, let's say, not filled already. And the way that I will define this is, again, very similar to what I had done above. So I have the character, tic-tac is the name of my variable that will keep this particular table, 3x3 table in memory. And then 3x3 is actually this is within square brackets 3 and another square bracket 3 would mean that I have 3x3 table. And this is how I would actually define it. And this entry here is going to be accessed by, if we use a convention of a table with, let's say, rows here. This is the first row here. This is the second row. This is the third row. And the row access is going to be by the first index here. And then the columns, these are the columns, column 1, column 2, or column 3. Or you can, if you think about the indices, since our indices starts with 0 in C, then 0th column, first column, and the second column. And the second entry here within the bracket will mean that the column number that I am interested in. So if I want to get to this guy here, it is clear that this is the first row, or the index 1 row and index 0 column. If I want to actually get to this guy here, this is very simple. This is tic-tac, right? Which entry is going to be? First, the row entry, which is 2, index 2, and then the column entry, which is index 1. Now, I can use this particular thing, tic-tac, open bracket 2, close bracket, open bracket 1, close bracket, as a variable to represent this particular cell. If this is, let's say, on the right-hand side of an assignment, for example, I can say this is X. Now I'll be writing X to that field in memory, or I can use that thing to actually get the read for that entry and use it perhaps in a expression, right? So there are the usual way of declaring such a multidimensional array is you have the type of the element, the entry, each entry type. Of course, we have only one type in this case, right? So all the tables should be having the same type element entries. And then the name of the array. So this is the type here. This is the name. And then however many dimensions that you want to have. And for each dimension, you want to have the size of that dimension. All right, this is perfectly easy. This is what we have done before. For a single dimensional thing, we only had one dimension here. Now we are adding a second, a third, and however many we want to have. Okay, so very simple. If I want to pass this an array, a multidimensional array, to a function, very similar to before, what we are going to do is we are going to actually use, if it was, let's say, a single dimensional array, we would have a type, the name of the thing, and the name of the parameter, local name of the parameter in a function. Let's say if it is integer foo, like this, right? So we would usually have an n here. So this will be a single dimensional array. You see that our definition does not have the specific size that we will actually not have the size because we would not, in general, know the size of the array that we are sending to a document or sending to a function. In this case, though, with the multidimensional array, you may not know the first, or you may ignore the first part of the, or first dimension, the leftmost dimension of the array, but the other dimensions should be actually specified. This is a must, and this will be clearer when we talk about in-depth pointers. And when we talk about pointers, we'll know why this is so, actually, that we have to have the second dimension, the size of the second dimension, the size of the third dimension, and so forth, has to be defined in that definition. So you see, for example, here some examples. I have a two-dimensional table. I define the number of rows to be 10, number of columns to be 100, again 10, and then I want to have a double table, a double entry table with double entries, and I have n rows times n columns entries. So there are number of rows is 10 and number of columns is 10 in this particular case. And I have another integer array, which is labeled, named as TT. And this is a three-dimensional table or three-dimensional array. And the first dimension is seven-dimensional, seven entry, seven, let's say it has seven different cells in the first dimension, 5 cells in the second dimension, and third size 6 is the or 6 is the size of the third dimension. All right. Now, if I want to actually call, let's say, send this table entry, table variable as a argument to a function, I would use something like this here. Right here, you see that I would have the type should be the same as double. Label, the name of the argument doesn't matter. It could be anything. In this case, I keep the same thing, but it doesn't need to be the same thing. And then the first dimension is going to be unknown. It's not going to be defined. It will be any number. I don't care about that number for the time being. And then, but the rest of the dimensions has to have the sizes defined. How many entries in each dimension you would have will be defined. In this case, I have only one more dimension, the second dimension, and I would actually put the number of columns or the number for that dimension fixed. Otherwise, I cannot actually call this one. So I cannot call or write a function that is, let's say, having nothing here. This is not allowed. All right. Of course, since I don't know the first dimension, the size of the first dimension, then I actually put the number of rows as an argument to this function, so that the caller of this function will tell me, okay, the definition tells me how many entries there are in the second dimension, but the definition doesn't tell me how many entries we have in the first dimension. Therefore, I will actually define that dimension as an argument, or I will send that dimension, size of that dimension, as an argument. Similarly, here you see that the first dimension is not defined, but the number of entries for that dimension is going to be an argument to a function. So you might ask the question, why don't we actually have a definition like this? A void, let's say, process matrix and double, right? An array. I'm trying to rewrite this thing here again. And why don't I actually say it this way? N rows and n columns, right? And that's it. Can I actually do it this way? Can I define this function or declare this function with such a notation? The answer is yes, you could do it, of course. But what this tells you is that the input argument to this function should specify, should be exactly the n rows and n columns. The definition should be exactly the same. So you would not have any flexibility of changing. For example, you might have another double entry here, double matrix, let's say table 2, and you might have, let's say, n rows times 2 times the n rows, and the same thing, n columns. Now, in this case, you cannot send this matrix or this two-dimensional array to the function that I wrote about, this PM function. You can send it to this function because the 2 times number of rows versus 1 times number of rows doesn't matter as long as you actually define this n rows properly. Whereas I cannot send this guy to this function, this thing to this function, because this function requires exactly n rows and n columns entries for the first and the second dimension, whereas this guy has twice as many n rows and the same number of columns. So this is the rule that you would use to define this thing. So let's, for example, we have a function here that checks if a given tic-tac-toe board is completely filled. Now, if you see here, I am actually defining the tic-tac-toe here as an argument to this function, a fully defined, fully determined in terms of sizes of first and second dimension. So I'm defining a character array, double array in this case, two-dimensional array, both dimensions having 3 entries in it, 3 different entries. All right. Since a tic-tac-toe board cannot be anything but a 3 by 3 matrix or a table of 3 rows and 3 columns, I don't need to actually change, or let's say parameterize the number of rows here. It doesn't make sense to parameterize it because I am sure that I'm gonna be calling this guy always with a defined 3 by 3 matrix. All right. In that case, I can safely write this one. If I didn't want to do, or if I didn't want to restrict this to be a 3 by 3, it could be n by 3 table, so more than or less than three rows, then I would have actually done differently this definition, this declaration, as we have done in the previous slide. So now what this thing wants to do is it wants to see if my tic-tac-toe board is actually filled. For a tic-tac-toe board to be filled, we need to check each entries. The entries are in principle what? TT, let's say TT board here. So the 0, 0 entry, the first one. So if I have it here, right, there are 3 by 3. This is the 0, 0 entry, this one. This is the 0, 1 entry. This is the 0, 2 entry, and 1, 1, 1, 0, sorry. 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. All right. So I need to go over each of them. I need to check if each entry is either a O, character O, or a character X. If that is the case, I will know that this particular thing is filled. This particular tic-tac-toe board is filled. So how do I do that? I need to go over this thing and check each of these. First this one, perhaps then this one and this one, and then this one, and then this one, and then this one, and so forth. So in this case, this is very easy to see that actually I need to actually have a kind of a nested loop. The first loop goes over each row first row and for each column of the first row, and then the second row for each column of the second row, and for each column of the third row, right? So then what I do is I have here a loop, a counting loop that starts from 0, goes till less than 3, meaning 0, 1, and 2. And then this will be actually going over the rows one at a time, okay? And then for underneath, for each of these rows, I need to go over each column on each row, right? So then I have a column counter from 0 to 3, not including the third one. Then now I am actually going over first each row. So R goes this way and C goes this way from 0 to 0, 1, and 2, 0, and 1, and 2. And then I'm checking in this case if it is empty. If there is an empty, that means that the answer to my field is this field should be 0, should be negative. If this is, so I assume in the beginning that my board is full, and then I am checking if there is any empty entry. I'm changing my answer to be no, it is not filled anymore. And at the end, I am returning that thing. All right, this is nice. This is quite easy, right? Perfect. Let's write another function. Let's see that. Let me see if I have it here. No, I don't have it here. But let's write another function that will return. So let's do it this way. Sublime here. So not this one. Let's open up a new file as my, let's say, test C. So I want to write a function that will return an integer counting the number of x's in it. All right. So I want to count the number of x's in a given, let's say, a given tic-tac-toe board. So number of x, let's call it this way. And of course, my array is tic-tac-toe. This is a tic-tac-toe board, which is a 3x3 board, right? This will be my entry, all right? So what I want to do now is I want to count the number of x's in this thing. So if you look at the original board that we have here, this one, you can see here that I have 1, 2, 3, 4, 5 x's. So I want to actually count this one. This is very similar to what we have done before, right? When we do the filling or the fill check. So I will have a counter for my rows and columns, and I will actually go for each row. So from row 0 to row less than 3, this one, this goes actually after each row. And then I want to actually do for each column for this row, for row 0 or row 1 or row 2, right? This way. And then I'm going to check if the board has at this row and at this column, right, is an X. If it is an X, then I will count an answer. This is integer, let's say my count, which is initially 0. I don't have anything in the count, and I will just increment it by 1, and then my function will just return with it, right? So this way, this will count the number of x's in it, right? It will say, okay, if I have an entry, let's say like this one here, this will actually give me the number 5 as an answer. All right. So let's actually write a test function for this particular case. Now, what I want to do is I want to actually see how I can initialize an array like this. All right. So I want to declare the array. It is gonna be a character array, right? So this is a character array. This is tic tac, and I know that it is 3 by 3, right? Now, the first question, and then I will actually call this number of x function with tic tac, and I will say, for example, here printf the board has this many x's. So let's do it this way, and I can now do it this way, right? So I am sending tic tac to this function to count the number of x's, and I am printing it here. So my question is gonna be, how do we initialize this board? One possibility is, let's say, I want to initialize this board very similar to what we had before. What we have here. So let's look at what we have here. So let me actually get rid of this guy for the time being. What we have here, the first entry is x, the second entry is 0 or O, sorry, and the third entry is an x, and the fourth entry, meaning this entry here, is also O. So let's see, the 0, 0 entry is an x, and tic tac 0, and the first entry, the meaning the 0th row, and the first column, the column number 1, is O, like this, not 0, of course, an O. And tic tac again, the first row and the second, third, or the 0th row and the second column is gonna be an X as well. And I will continue this one 3 more times for each row. This is the first row, this is the second row, and so forth. This is the first row, and this is the last row, right? And then I have to actually put the same things here. Let's say 0, OXO, this is OX, all right, O here. And the last row is 0, OXX, O, X, and X. All right, so this is fine. This is how I would actually populate this thing. So you may want to ask the question, can I actually do this initialization in another way? For example, can I, let's say, do something like this? Instead of doing this one, can I hope to, let's say, do something like this? I don't know, perhaps. So does it work? This seems to be a good idea, right? I know the number of rows on the, or the number of columns of this row, the first row. Can I actually do this one? The answer is no, you cannot do it. This is not a way to initialize it. There is no way that C will allow you to actually have an assignment statement where on the left you have an array, not a single entry, but an array entry. And then on the right, you'll have multiple entries like this. So this is not possible, but C allows you to do some things. C says, okay, if you know from the beginning what you want to actually put in this thing, you can use as we did before for single arrays. For example, if I had an array, for example, let's say something like this, let's say this one, I knew how to actually do this one, right? So I would actually put, let's say A, B, and C. This says that actually I am initializing my str array, a three entry array or size 3 one-dimensional array with A, B, and C, right? This could have been anything. So if I want to actually put it here this way, this is also working, if you recall from our discussion for single dimensional arrays. So does it happen for a multidimensional array? And it seems that C can actually do that one for you, but it will actually do let you do it this way. It will say, since you have 3 rows, this is assuming that you have now 3 rows of this thing, and for each row you have 3 entries. So this is the first entry X, this is the second entry O, and this is the third entry X again. And similar thing will go for the second row. So maybe we can actually do something like this to make it a little bit readable. And this is gonna be the third entry here. And this first entry was, let's say, this one and this one. And this is X, and this is X, and this is O. So C allows you to do something like this. This is also possible, but this is something that actually C allows you to do in the very beginning if you know how to initialize or what to put in this array. So now the important thing is that this inside ones, these ones, have to be for sure the same size as this guy here. All right. So this is supposed to be this way. All right. Do you have any questions? Let's see if there are any questions here. No, there are no questions. Everybody is happy as right now. Okay. Good. So this is number of X, counting the number of X. So what else can we do here? Let's actually try to print this thing out. I want to print my let's say I want to have a function that prints tic-tac-toe game. So given a board, I want to print it. So how do I print it? It's very similar, right? I need to actually print each row one at a time, and for each row I will have three things to print. Let's say columns to print. So this is each row, then this is each column, and I want to just print it. Of course, what I want to do is I want to print this guy. So print F. This is a character. I'm hoping to have a space in between, hopefully, and I want to actually put my tic-tac-toe board here for entry R and the row R and column C. What this will do is this will actually print each row each entry one after another. So for this particular thing, what it will print here is something like this. So it will print X, O, X, O, O, X, O, O, X, X. I didn't want to do it this way. I want to actually put a new line after each row. So if you want to put a new line after each row like this, then you go back and you say, okay, where do I actually put a new line? Where do I actually change the code to put a new line after each row? Can you answer me? Please write it down. If someone can write down, or maybe some of you, in which line should I actually put a new line here in this code? From lines from 1 to 9, I want to insert a printf new line character so that instead of actually having a single line of entries like this, I want to have an entry like, or an output like this. So which line? Which line should we put this printf new line? 7th line, between 6 and 7, 7th line. Okay, so there are some answers. Let's see. The answer is correct. So we want to actually put it here because this guy, 4 and line between 4 and lines between 4 and 6, would actually print 3 entries, and then after each 3 entry, after each row is done, I want to actually go to a new line and start a new entry, a new row. Therefore, I would put a printf new line here. And this would actually show me a board similar to this guy here. Similar to this one here. So let's put it here so that example output is gonna be something like this. Perfect. So if you wanna actually, let's say, let's do it this way. What I wanna do is, I don't like it this way. I wanna actually indent this part. I wanna put, let's say, 4 spaces here. Okay, how many? 4. 1, 2, 3, 4 spaces. And here also 4 spaces, and here 4 spaces. What do I do? How do I change my code to do this one? Okay, this means that I'm gonna put 4 spaces somewhere, and I wanna print 4 spaces. Where should I do that? In which line should I actually insert a code, printf just 4 spaces? Which part of the line here? Remember, be careful that actually the line numbers have changed. So from between 7 and 16, where do you want to put a printf where I start actually my rows, or my each row should start from after some indentation, in this case 4 space indentation. You can appreciate that I cannot put it here. If I put it here, it's gonna be just actually separating these individual entries from each other by 2 instead of by 1. So there has to be another place where I can do this one. Let me see if you have an answer. Between lines, and yeah, that's good. So in the beginning of the first loop here, between line numbers 9 and 10, if I put just a printf, as someone suggested, 1, 2, 3, 4 spaces. So 1, 2, 3, 4 spaces, then I'll be done. So this would do, for each row, it will first put 4 spaces, then it will print with a space separated characters for each row and each column for that particular row. And then it will actually finish that row by going into a new line, the next line, beginning of the next line. When it goes back to here, it will actually print that 4 spaces and then the entries for that row and then a new line and so forth. Okay, this is good. So you can see that I can now using 2 loops, nested loops, that I can actually go through this entire thing and print it or print it in some way. All right. Okay. Perfect. So let's continue. So we can, let's say, if we, let's talk about some representation for a maze game. Let's assume that I want to define a maze like this. And here I want to have free spaces indicated by the white cells and spaces that I cannot go on. These are the black ones that I can, these are the walls that I cannot go through or occupy. And the red one is my starting point. And the blue one is, this is my starting point. So you can see that I cannot, this is what I am defining for the time being. I am saying that, okay, I cannot, I can be here in the beginning. This is the starting point. I can go to, let's say, to the bottom, or to down. I can go up because it is empty, indicated by a white cell. I cannot go this way to the left or to the right because those 2 cells are occupied by a wall. It is a wall. And what I want to do is, perhaps I want to write an algorithm at the end that starts me from this red cell and then finds a way and gets me to this blue cell. And this is what I want to actually write. So let's talk about first how we can simply represent this as an array. How many dimensions should we have for this array? I'm asking the question, please someone type. 2. All right. So it's obvious, right? So I have one dimension here and another dimension here. So the second question, what type of entries should I have for each of these cells? What do you think? What type of entries? Integers, okay. Maybe int, okay. How about characters? Can I have characters? Someone answer? Yes. Because I mean, what do I need to do is I need to actually know how many values I want to have here. So what type of values do I have here? I know that this could be blocked. It could be free to move. And then you have the start position and we have the end position. So we have actually 4 different values. This is nice. If we have only 4 different values, can I use integers? You said already yes, why not? I can say blocked is 1, for example, free is 2, start is 3, and end is 4. Can I use something else? Perhaps why not? I can use characters. If this is characters, I can say, let's say block is B and free is F and start is S and end is E. These are the characters. Why not capital? Well, why not? Can we actually use something else that we know of? Can someone suggest any other way? Yeah, someone said enumerated type. This is very nice, right? These are 4 different values that I know of. They should be enumerated. Now, if you recall, we could have defined an enumerated type. So if you recall it, we say type def enumerated. We say, I don't care what the value of block is gonna be or free is gonna be, or start, maybe, I don't know, this is start and end. And this is my, let's say, maze type, M type. And then now I can describe or I can declare my variable to hold this thing. So the first thing that we need to decide is, okay, now what I'm going to do is I'm going to say M type. This is my new type. And then the name of the thing, maze. I want to name my variable maze. And I know that this is going to be 2-dimensional. Someone said that this will be 2-dimensional, right? Now, how many entries in the first dimension? Someone tells me in this particular case, how many entries? I'm waiting an answer from someone. So 6. Why is it 6? Let's see. I have one row here, another row here, another row here, another row, another row, another row, another row, another row. How many rows do I have? 1, 2, 3, 4, 5, 6, 7, 8 rows. So this should be 8. How about the number of columns? Similar, right? So I think the person that actually write an answer as 6, he thought actually, who was he? Let's see. It was Jakub Han. Jakub Han told that actually maybe we are interested in only this part of the thing. But we need also know the boundaries. So it will be better if we have actually 8, right? So the same thing for the number of columns. It's very similar, right? So if you look at the number of columns, 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna be an 8 by 8 2-dimensional array. All right. So then what I want to do is, let's say let's write this and perhaps let's initialize this particular thing in a function. This nice game or maze that I have. So what I want to do here is I want to turn on this guy, and I want to do, let's say, a new file here, and I want to say this is my maze.c, and I want to have a function, a void function that would actually populate a sample maze, a maze sample 1. And the maze is going to be, again, in this particular case, so we know that it is supposed to be, we need a type definition here, first of all, type def. We said the type def is going to have enumerated, right? And then we said we would have blocked. And we said we had free. I have to be a little bit careful with these words because they may be reserved words. So I'm going to actually change this one: maze blocked, maze free, maze start, and maze end. This is what I want to do. And this is maze type. All right. And then I would have here maze type, my maze, right? And I know that I need to actually now do something here. This is what I want to actually have here. So I need to define the entries, the number of entries that I have here. So for this particular board, I know that I have 8 things. So define num columns is 8. And I have also num rows is 8. So I would actually use number of columns here. So if you knew that your number of rows is not going to change, perhaps you can put your number of rows here. This is a possibility, but we usually don't want to do that. But let's say that we want to do it this way. So now I have this particular maze type, maze sent to this thing. And I want to actually initialize this thing to this particular thing. So let's do it. It says the first entry, 00 entry is blocked, and all these first entries is blocked. Seems that everything is blocked except some of the entries. So let's actually fill this thing in with everything blocked. So let's say if I want to actually say everything is is blocked, then I would say for start from this first row to num rows, and this one, of course. And then for each column, as columns are number of columns, plus CC. And what I want to do here is I want to actually take my maze, and for each row and each column, I want to make it M blocked. You see now that I am actually putting, so make the maze blocked, all walls. All walls are blocked. Okay. Are we running out of time? Yeah, actually we went too far. Okay, let's do it this way. Let's stop here and take a 10-minute break. We're gonna continue around 2:38. All right. See. Keep this one. And let's go here. Don't go anywhere. We'll be starting again at exactly in 10 minutes. So I'll stop the recording.